Hi, everyone, and thank you for having me. My name is Ramtin Davanlou, and I'm a senior manager from Accenture Applied Intelligence practice. I'm going to talk about our latest innovations, trying to make artificial intelligence applications more cost efficient, which leads to increased AI use cases that are economically justifiable, right? So that's a very important point because there are many imaginable use cases for AI that, just because of their costly implementations are yet to be implemented, right? So, what we do is we try to help industries take advantage of AI for process automation, demand forecasting, customer care, quality management, even things like fire prevention, with what we had in West Coast recently, and other things like workplace safety and many other use cases, right? And what we're doing is we're trying to give computers ears, eyes, hands, and a tongue and a brain, right? So that they can do things for us, right? It's, for example, we're using computer vision to help identify and separate defective products in a production line, right? Or even using voice recognition and natural language processing to identify an angry customer and direct them to the right representative. We are using computer vision to help preserve our planet's beautiful coral reefs, right? Which is a very interesting use case that we had. And also using it for medical image processing to more accurately identify potential health issues, right? So all of these use cases are compute intensive, right? And they require long cycles of development, deployment, maintenance, using huge amounts of data, right? Our main objective here is to find ways to make AI platforms more cost efficient by a combination of improving the compute architecture in the hardware and infrastructure piece, and also software optimization on top of it, right? So the combination of these two. Let's start with compute architecture, right? These days, we see a huge trend of migration to the cloud for obvious reasons, right? Companies love the cost savings that a pay-as-you-go model can offer. On the cloud, one of the most popular ways of accessing compute resources is through starting virtual machines, right? These virtual machines typically have pre-configured resources such as CPU, RAM, network, and others. And they come with a variety of these pre-configured combinations, right? And with different pricing. And that, obviously has a huge impact. The type of instances and virtual machines that you pick has a huge impact on the end results for you, right? So how much your platform costs, right? And how economically feasible that would be for a specific use case. So what we do is we have recurring benchmarks and evaluation, trying to understand the performance and cost implications of choosing these different virtual machines. And also thinking about what are some software optimizations that we could do to achieve the best price to performance for AI and machine learning workloads. We looked at two software optimization opportunities here with things that were made available to us by Intel in this case. So there's, Intel distribution of Python. There's Intel extension for scikit-learn. And there's other advanced optimizations with TensorFlow, with things that are available through what's called one API and one DAL, which requires additional changes in the code to make that happen. So to achieve this, we collaborate and co-innovate with Intel. to make sure that we bring the latest and greatest technology to our clients. And I'm very proud of what we've achieved together in this partnership. So in these benchmarks that we run, and in this slide, you see some of the results of the benchmarking work that we have done. As you can see in these charts, we have different processors, and we have results with and without software optimization, right? So going from left to right, on both charts here, you can see, first is, an instance with, the latest Intel CPU in it. At the time of this study, it was Cascade Lake. Now we also have Ice Lake available on AWS, for example. But you can see, Intel instance without software optimization. The next one, the darker purple, is another instance, ARM-based instance called Graviton, available on AWS that we've tested for this study. And then the next one is the same Intel instance now with scikit-learn optimized, right? The extension of scikit-learn that is optimized, and you can see huge improvements in performance there. So that's the darker purple. And the darkest is actually using OneDAL and OneAPI libraries to achieve that type of optimization that you can see there. So as you can see here, both for software optimized versions, in both cases, we have a huge jump in performance. And this chart shows number of times better, right? For each of these, popular algorithms that we see, like linear regression, logistic regression, random forest, k-means, and others. And so in this slide, all we're looking at is performance, right? What is the performance gain that we can have without considering the cost implications, right? And we're going to add cost to the equation on the next slide too. But just discussing this a little bit more, this is about making sure that we look at different choices that our clients have in terms of the compute resources that they're going to consume, right? And trying to see what is the best choice for specific types of workloads. So here you're adding cost to the equation as well, right? So because these instances are priced differently, and those prices change, periodically and actually very often. So we need to make sure what is the implication of cost and performance together on these workloads, right? So when we do that, you can actually see, even a bigger improvement for AI training and inferencing workloads, right? So between even achieving up to 25 times better performance, right? With Intel optimized scikit-learn and OneDAL, right? In closing, the combination of correct hardware choices and software optimization can provide significant cost-saving opportunities for AI platforms. So this is what we're getting at. We are trying to make sure that we take advantage of, understanding implications of hardware and software choices. And cloud providers offer many choices for varying compute resources, and they price them in the form of virtual machines or managed services. And this makes it very difficult to pick the most cost-efficient option for your particular AI workload. And what we understood was that upgrading to virtual machines or compute options with the latest processors, and in this case, latest Intel Xeon processors, and taking advantage of software optimizations are ways to continuously reduce your TCO. And with that, I'll pause, and I ask the panelists to ask questions.
Yeah, thanks, Ramtin. My name is Chris Grundeman. I run a shop called Grundeman Technology Solutions, and my Twitter handle is @ChrisGrundeman. And I just want to start with some kind of basics here. When we're looking at those charts, I mean, obviously some of the improvements are striking, but just fundamentally, what's the baseline there? When we're saying times better, I'm just wondering, what's the reference that's the 1x? And when we're saying like performance is 9 times better, does that mean the training happens 9 times faster, or what are we actually saying by, like, again, what are we comparing to and what are we saying is better specifically?
Yeah, thank you, Chris. Great question. So this is, so going back to these charts here, right? The baseline is the first benchmark that we ran, right? And this is, we picked one instance type and, assumed it was one and normalized everything else based on that, right? So the first instance that we choose is an Intel instance, right? And in this case, so this is one, right? And everything else is compared to this one that we have here.
Sounds good. And then when we're saying the performance gain, I guess what specifically do we mean by performance there?
Right. So this means different things for training and inferencing, right? For training, it's usually around the execution time, right? How long does it take for you to train your algorithm using the same size data, right? That we have, and for different models that we have here, the data size is different. We have also deep learning benchmarking, that involves much larger data sets and different algorithms. So that's for training mostly, and for inferencing, it's mostly around throughput, right, and latency. Right, this is about how many inferences you can do per second, right, and what is the response time, from the time that you submit a new inference and you get the results. Yeah.
This is Calvin Hendricks Parker. Again, I wanted to ask a question about the deployment of this. I was looking at the various packaging options for the Intel optimized Python, which I didn't know actually existed. I'm pretty excited to find and discover this, but it seems like it's yet another packaging of Python. Are these proprietary changes to Python that can't be upstreamed or to those various open source packages that you are using like scikit-learn, or is this something that is just so specific to the Intel processor that it wouldn't make sense to go into those distributions?
Yeah, great question. These are all open source and available online. So it's a so in case of Python, this is just a library that you can download, and it's a simple pip install command, right, that you can do. In case of one API and one DAL, it involves making minor changes in the code as well to try to add those, but in terms of acquiring it and using it, it's all open source.
Yeah, but it seems like it's always a version behind on Python though, right? Right now you just added 3.8 support. It looked like it's really supported on 3.7, but 3.9 is just released and 3.10 is knocking at the door. What does the support and timelines look like for getting these releases so that we can always be using the latest versions of some of these tools?
Yeah, great question. I think that's always true, right? So it's always lagging behind a little bit. The fact is, a lot of companies, a lot of our clients are already using older versions of Python. They wait until things are mature, until they start using it, right? So that actually doesn't impact us that much. But I think we are trying to close that gap too, right? Trying to bring things sooner to the market, and in addition to what's available by Intel, we add all of these optimization work that we do together with specific AI use cases in GitHub, right? Trying to make them available in open source way for everyone who wants to use it.
Hi, I'm Athar Baig. I'm an enterprise solution architect with Rackspace Technology Limited, and my Twitter handle is @Athar Baig. I was just wondering, actually, this study that you've done, first of all, I mean, you mentioned that you have to run it on AWS. So I was wondering if this is a study to just specifically prove a point where you can use software optimizations to increase performance, or get those performance gains if you pick the right processor, because sometimes different clouds, you can't pick the one that you want. So is the aim to just prove that theory, or is it a tool that you want to develop for your customers, so that going forward, as more processes come along and more platforms and more instance types, and then you can say, okay, this is the one that's the best one for you?
Right, right. Great question. So we do this, periodically based on what our platforms and offerings need, right? Because we have larger AI platforms and offerings, targeting different functions of organizations or different industries. And all of those solutions and offerings, they use, cloud infrastructure a lot of times, right? And we have this piece of our solutions that we call solution workbench, which helps our solution architects basically pick the right infrastructure for that platform when they customize it for a specific client. So this is just an example, and that came up from one of those offerings and platforms, right? Because they were facing this question of, do we choose this instance type versus that instance type, right? And we solved it by running these benchmarks. And that's what we do for basically trying to prioritize, what are the questions that our solution architects for different offerings are asking, right? And trying to answer those questions and helping them make better decisions when they are tuning the infrastructure and also adding the software optimization on top of it. So it's basically this is just example of the work that we're doing. There's hundreds of other tests that we run on a recurring basis, but at the end of the day, this effort is trying to answer questions raised by hundreds or even thousands of solution architects that we have globally trying to deploy these solutions.
So I was then wondering that, do you want to, or would you like to then keep doing these for all the different permutations? So help your solution architects doing that going forward? Or
Correct,
is it,
exactly,
again, as it comes along?
Exactly. So both, as it comes along and as we get new questions, right? So we determine when we want to run the tests and what types of tests.
All right. Thank you.
Thank you.
Hey there, Chris again. One final thing, I guess, obviously, as we can see from this data here in these tests, the software optimization makes, a huge improvement, especially when we're using, one DAL and one API there. Are these optimizations that you're using in the testing, are those something that are shared, or is that something that's proprietary? Right. I mean, can I go, get the recipe for optimization for, DB scan with one DAL somewhere?
Right. So we share this. So a lot of this is what we do internal, but we're also publishing the results, periodically, as I said, in GitHub, make them available publicly, right? Because a lot of these are tuned for our use cases internally and the offerings that we have at Accenture, right? A lot of times, it's us working directly with those engineering teams trying to make these available to them, but we also publish this on GitHub and it's publicly available, but that's going to be like longer cycles, and we have done, I think, 2 rounds of this recently.
And this goes back to actually something Gina and Chris both asked, which is the types of instances that you ran these benchmarks against. Is it possible to see those historically? Like if I can see it against like a C4, C5, all the way back to like, C2, to see what the differences in those generations have brought, whether there was, increases or declines. It seems like you've got one instance type here. We're not seeing the other kinds of instance types.
Yeah, that's a great question. We have a lot of these tests, as I said, but we cannot fit all of that in one chart. And
right, but we need to have the data published someplace so that those who are using this as a guidebook or a playbook for how do I get the best bang for the buck? It seems like that's the whole point. You really only exposed one instance type here.
Right. That's right. We try to, there's a couple of things here. One is the price changes over time, right? And that, changes all of these results, right? So you can have, something that's performing better now, but just because the pricing has changed, now it's, it's not economically justifiable, right? So, so that's one thing. And the other thing is, really, as I said, this is, about answering specific questions by people who are making these decisions, right? And a lot of times you have, instance types that are making better sense for your use case. So for example, if you're using Spark, you need more memory, and your instance type of choice on AWS, for example, would be, our instance types, right? So you want to compare those instance types against each other or against, other processors that are available. So yes, so we have a, large directory of, all these test results. And, because we try to use the same frameworks for benchmarking, it's all comparable. You can compare things against each other, but that's, that part of it is more kind of proprietary, right? It's not made available public because of different reasons. Okay, thanks a lot, everyone, for having me, and thanks to the panelists for great questions and very to the point and correct ones. And we continue doing these performance optimizations using both hardware and software choices that's available to us. Please reach out to us if you need more information about this, and we're happy to support and help.